Happy New Year, January 1st, 2023. 7 examples, lucky 7. Recall that if you have 2 linear equations, you could graph each of those equations and find out the intersection point. That would be the solution to the system. However, there are other methods. This method is called substitution. You have a few decisions to make. The first decision is to look at each equation, equation 1 and equation 2. You want to isolate one of the variables in one of the equations to start. Equation 1 is a lot easier to isolate one of the variables compared with equation 2. You can choose either variable, and as you practice, you'll get better at choosing one that works best in the second equation. For now, let's just isolate the x. In order to get x by itself, we're going to subtract y both sides, because that creates a zero pair on the left side, leaving the x by itself. What we do to one side, we must do to the other. You could also write this as negative y plus 2. The order doesn't matter. We'll take this value for x and plug it in where we see an x in the second equation. Rewrite your second equation and make sure you leave yourself a lot of room. Keep your equal signs all lined up if you can. When you line up your equal signs, you're better able to find mistakes when you make them. I rewrote the second equation with a bracket where the x was, because that's where we're going to insert the 2 minus y. I haven't changed the equation. The only thing I've done is change the look of the equation. We've rewritten the second equation so that the x disappears, which is quite nice because then we can solve for y. Make sure to follow your order of operations. We need to distribute first. 2 times 2 is 4. 2 times negative y is negative 2y. We have the negative 3y and the 9 on the right side. My equal signs are all lined up. Now I'll collect my like terms. I have 4 minus 5y is equal to 9, and I'll isolate the negative 5y by subtracting 4 both sides. What I do to one side, I must do to the other. That makes a zero pair, and we have negative 5y is equal to 5. I want y by itself. The inverse of multiply is divide. I'll divide by negative 5. What I do to one side, I do to the other. That makes a 1. Y is equal to negative 1. We found the y value, negative 1, but we're still looking for the x value. When y is negative 1, we'll use the second equation to find out the x value. We can insert the negative 1 where we see the y. 2x minus 3 bracket negative 1 equals 9. 2x, we need to multiply negative 3 times negative 1 is positive 3 is equal to 9. We want the 2x by itself. Subtract 3 to make a zero pair. 2x is equal to 9 minus 3 is 6. Isolating the x by dividing by 2, both sides. X is equal to 3. The x value we found is 3. But we should check our answer. We'll use equation 1 to check our answer. The x value is 3 and the y value is negative 1. Does that equal 2? 3 minus 1, does that equal 2? And 2 equals 2. We've found the solution to this system of equations. In Desmos, x plus y equals 2 is blue. 2x minus 3y equals 9 is green. And the intersection is 3, negative 1. 2 equations, 2 unknowns, solved by substitution. I'm looking at the second equation and it looks to be a little weird. There's a common factor of 2 here, but I'll just go ahead and solve it using substitution and see what we get. We can isolate the y value. Negative y is equal to negative 3x plus 6, but I also have to divide by negative 1. Y is equal to 3x minus 6. We'll plug that into the second equation. Line up our equal signs. use a bracket to substitute in the 3x minus 6. Follow your order of operations by distributing first. Negative 2 times positive 3x is negative 6x. Negative 2 times negative 6 is positive 12 is equal to 2. 6x minus 6x is 0x. Subtract 12 and we get a negative 10. Divide by 0 is not possible. 10 negative divided by 0 is not a number or undefined. What is the problem? Well, a couple things. You could use Desmos to double check and see what's going on. Or maybe you are thinking about these lines never intersect. How could you figure that out using algebra? We already isolated y here, and the slope is 3 in the y is equal to mx plus b form. The slope is the coefficient with the x. How about we isolate y here? Get negative 2y by itself by subtracting 6x. Negative 2y is equal to 2 minus 6x, or negative 2y is equal to negative 6x plus 2. Divide by negative 2. And y is equal to negative 6x divided by negative 2 is a 3x minus 1. Look at that. Slope is 3 here. What do we know about slopes? When two lines have the same slopes, they're parallel. They'll never hit. I think you figured it out. No solution, because the lines are parallel. In Desmos, 3x minus y equals 6 is the purple line, and 6x minus 2y equals 2, the blue line. Those lines are for sure parallel. They do not intersect. Next example, two equations, two unknowns. Solve for x and y so that these two equations are true. I'm looking at these two equations, and the second equation is an exact multiple of the first. But let's pretend we didn't notice that. We'll solve for x. Subtract 2y both sides. X is equal to negative 2y plus 4. And we'll substitute that value into the second equation. Line up your equal signs and set up the bracket. Insert the x value from the first equation. And now solve for y. We'll distribute. 2 times negative 2y is negative 4y. 2 times 4 is positive 8. Plus 4y is equal to 8. And we get 0y. Subtract 8 both sides is equal to 0. We are not able to divide by 0. What's going on here? Double check with your calculator and you'll see 0 divided by 0 is not possible. Undefined. Let's have a look at both equations. When we solve for y in equation 1, we'll subtract x both sides. 2y is equal to negative x plus 4 and divide by 2. Y is equal to negative 1/2 x plus 2. Second equation, we'll isolate the 4y by subtracting 2x. 4y is equal to negative 2x plus 8. Divide by 4. Y is equal to negative 2/4 x plus 2, or negative 1/2 x plus 2. Look at this. We have the same slopes, negative 1/2, and the same y-intercepts, 2. These two equations create the same line. There are infinitely many solutions for this system. In Desmos, x plus 2y equals 4 is in red, and 2x plus 4y equals 8 is in blue. It's the same line. Here we have two equations and two unknowns, and we're trying to solve this system by substitution. Isolate one of the variables in the first equation, and I think you can see that isolating x is the best choice, otherwise you have a negative. Add y, both sides. X is equal to y plus 5, or 5 plus y. We're going to use that value for x and insert it right there in the second equation. Rewrite the second equation, leaving yourself a lot of room to line up your equal signs. We're going to insert the y plus 5 into the second equation right there, and then solve for y. Follow your order of operations. When you're collecting like terms, we'll need to distribute first. 2y plus 10 plus 3y is equal to 12. Collect your y's. 5y plus 10 is equal to 12. Isolate your y by subtracting 10. 5y is equal to 2. Isolate y by dividing both sides by 5. And we get y is equal to 2/5. When y is 2/5, what is x? We'll use that same equation and insert the 2/5 right there. Line up your equal signs. Now we have 2x plus 3 times 2/5. You multiply the numerators and multiply the denominators. Reduce if possible. And we want to isolate the 2x by subtracting 6/5. Both sides. 0 pair. 2x is equal to 12 minus 6/5. Now we want to simplify the right side by getting a common denominator of 5. We multiply the denominator by 5, therefore we need to multiply the numerator by 5. 12 times 5 is 60. 2x is equal to 54 over 5. Now we want x by itself. Usually we divide by 2, but we have a fraction over here. Let's multiply by 1/2. Multiplying by 1/2 is the same as dividing by 2, and that will create a coefficient of 1 here. What we do to one side, we must do to the other. Our x value then is 54 divided by 10. That is 5.4, but we'll reduce this improper fraction. X is 27 over 5. We need to use that value for x to find out y. When x is 27 over 5, what is y? 2x plus 3y is equal to 12. We'll insert the 27 over 5. 2 bracket 27 over 5 plus 3y is equal to 12. 54 over 5 plus 3y is equal to 12. Isolate 3y by subtracting 54 over 5. 3y is equal to 12 over 1 minus 54 over 5. We need a common denominator of 5. Be 60. 3y is equal to 6/5. I hope you don't mind I erased a little bit here. 3y is equal to 6/5. Rather than dividing by 3, let's multiply by 1/3. What we do to one side, we do to the other. Those two cancel to give a 1. Y is equal to, now 6 is on the top, 3 is on the bottom. Let's reduce that first. Greatest common factor is 3. 3 goes into 3 once. 3 goes into 6 2. Numerator, we have 2. Denominator, we have 5. The y value is 2/5, and the x value is 27/5. But we need to verify and check our answer using the other equation. We'll use that point and check it in the first equation. X minus y is equal to 5. First equation, 27/5 minus 2/5. Does that equal 5? 27 subtract 2 is 25/5. Does that equal 5? And yes, 5 equals 5. We found the solution to this system of linear equations. In Desmos, x minus y equals 5 is green, 2x plus 3y equals 12 is purple, and the intersection is 5.4, 0.4. Using algebra, we got 27 fifths, so 27 divided by 5 is 5.4, and 2 divided by 5, 2 fifths is 0.4. We got it right. We have one equation, two equations. We're looking for the values for x and y that hold true in both of these equations. We'll solve for y by subtracting 3x both sides. Y is equal to negative 3x plus 14, or 14 minus 3x. We'll take that value and insert it in the second equation. We'll use the second equation. Leave yourself a lot of room. Line up your equal signs. 3 bracket and the 2x in front equals 12. We've created brackets for the y, and we'll insert the y value from the first equation. Follow your order of operations by distributing first. We have 2x. Positive 3 times negative 3x is negative 9x. 3 times 14 is 42, is equal to 12. Collecting our like terms. Negative 7x plus 42 is equal to 12. Subtract 42, both sides. Negative 7x is equal to negative 30. Isolate x by dividing by a negative 7. And we have x is equal to 30 over 7. When x is 30 over 7, can you find y? We'll use 2x plus 3y is equal to 12. And where we see an x, we'll insert this fraction, 2 bracket 30 sevenths plus 3y is equal to 12. 2 times 30 is 60 sevenths plus 3y is equal to 12. Isolate 3y by subtracting this fraction. 3y is equal to 12. Subtract 60 over 7. We need a common denominator. We times the denominator by 7. We need to times the numerator by 7. 3y is equal to 84 over 7 minus 60 over 7. 3y is equal to 84 subtract 60 is 24 over 7. Don't give up. We want y by itself. Usually we divide by 3, but we'll multiply by 1/3, the reciprocal, both sides. And y is going to be, let's reduce here. 3 is the greatest common factor. 3 goes into 3 once. 3 goes into 24, 8. So we have 8 over 7 for the y value. The point then is 30 over 7, comma, 8 over 7. But it looks a little weird. We better check our work. We'll use the first equation, 3x plus y is equal to 14, and plug in the x and y values. 3 bracket 30 over 7 plus 8 over 7. Does that equal 14? 3 times 30 is 90 over 7 plus 8 over 7. Does that equal 14? 98 divided by 7. Does that equal 14? 98 divided by 7 equals 14. It's true. The solution for this system of equations is 30/7, 8/7. Nicely done. In Desmos, 3x plus y equals 14 is in green, 2x plus 3y equals 12 is in blue, and the intersection is a decimal. Hard to see. 30 divided by 7 gives us 4.286, and 8 divided by 7 gives us 1.143. Do we really want to tackle this one by using substitution? Let's do it. 2 equations, 2 unknowns, solve for x and y by using substitution. I think isolating 3x might be the best choice by adding 2y both sides. 3x is equal to 2y, but we also need to divide by 3. Divide by 3, divide by 3. X is equal to 2y over 3. Take the second equation and we'll insert the 2y over 3. We must do this part first. Multiply the numerator and we get 18y, and the denominator will be 3 plus 4y is equal to 5. We're lucky 18 divided by 3 is 6. 6y plus 4y is equal to 5. 10y is equal to 5. Dividing by 10, y is equal to 5/10, or y is equal to 1/2. You always want to reduce. All right, when y is a half, what is x? And let's use the second equation again. 9x plus 4y is equal to 5. Plug in the half right there. 9x plus 4 times 1/2 is equal to 5. 9x, 4 times a half is 2. Isolate 9x by subtracting 2 both sides. 9x is equal to 3. Divide by 9. Divide by 9. X is equal to 3/9, or x is equal to 1/3. We found x. We found y. X is 1/3. Y is 1/2. But we should check. We'll use the first equation. 3x minus 2y is equal to 0. The x value is 1/3. Minus the y value is 1/2. Does that equal 0? 3 times a third is 1. 2 times a half is 1. Does that equal 0? 0 equals 0. We know that 1/3, 1/2 is the solution. Excellent. In Desmos, 3x minus 2y equals 0 is in blue, and 9x plus 4y equals 5 is in green. The intersection is a decimal, but you probably know 0.3 repeating is 1/3, and then 0.5 is 1/2. 1/3, 1/2. I know we've been looking at fractions in our examples, but now I want to focus on decimals because for some of the word problems you'll work on, you'll be working with money. You'll be needing 2 decimal places for your answers. So let's do a question like that without having to focus on the word problem. We have 2 equations and 2 unknowns, and this time our unknowns are a and b instead of x and y. We're asked to use the substitution method, so you don't need to worry about graphing. But if you did rely on Desmos or try to graph, then realize that you need to define the axes. For the x-axis, you can choose either one. You can call it the A, and for the y-axis, you can call it the B, the A and B axes versus x and y axes. And that's fine. And it doesn't matter. You could put B here and A here. We'll start by isolating A For equation 1 then, A is going to be 2022 subtract B, and we'll take that A value and substitute it into the second equation. Leave yourself lots of room. Try to line up your equal signs. 2022 subtract B goes in the brackets in place of the A. And now we'll distribute 0.08 times 2022, 0.08 times 2022, 161.76, and 0.08 times negative B plus 0.06B is equal to 151.32. Combining like terms, 0.08, which is minus, plus 0.06 is negative 0.02B, and we had the 161.76. We want to isolate the B. We'll subtract 161.76, both sides. 151.32 subtract 161.76 is negative 10.44, and that's the zero pair. We'll have negative 0.02B, and we want B by itself, so we'll divide by negative 0.02, both sides. Negative 10.44 divided by 0.02 negative equals 522. B is equal to 522. We found the B value. We need to find A. We'll use the second equation. We'll plug in B. We have 0.08A plus 0.06 times 522 is equal to 151.32. 0.06 times 522, 31.32. 31.32, and we want A by itself. We'll subtract 31.32, both sides. Zero pair, 0.08. A is equal to 151.32 subtract 31.32 equals 120. We want A by itself. We'll divide by 0.08, 120 divided by 0.08, 1500. But we should check. We'll use the first equation and plug in the A and B values. 1500 plus 522, does that equal 2022? 1500 plus 522. And yes, it does. We found the solution to this system. And if you use Desmos, you can't use A and B. Here, X is the A, Y is the B, and when these two equations are graphed, we get a solution of 1500, 522. Onward we go to 2023. Good job.